All right, yesterday we introduced probabilities. Today we got the probabilities of disjoint, or also called mutually exclusive, and also overlapping events. So more than one event taking place at the same time. All right, three big words here you need to make sure you get down. First one is called compound events. Compound is the union or intersection of two events. That would be this picture right here where you combine everything in event A, everything in event B, and you combine all of them. That's called a compound event. Overlapping, if they have one or more outcomes in common. Really, like if you look at the intersection right here, they do have some things in common. A and B do have things in common. Those four dots in the middle, those are called overlapping. Disjoint, or most books use this word, mutually exclusive, if they have no outcomes in common. That's what this is. Also, the symbols. Let's look at some symbols here. The symbols for union is this right here. It's like a U, but it's not truly a U. It's a symbol like a U. Intersection, they use this symbol. It's like an upside down U. So that means intersection. So the intersection is empty. That's intersection. Union, if you do everything, that's union. All right, probability of compound. Okay, here we go. If A and B are any two events, then the probability of A or being a huge word here. Anytime you see the word or for the next few days, I want you to think it means addition. So what I'm going to do, if there's two events, I'm going to add their two probabilities together, but be careful. You have to subtract out anything they have in common. Right now, if they're disjoint or mutually exclusive, that means they don't have anything in common. You just add the two, P of A plus P of B, probability of A plus probability of B. Now, again, if they have stuff in common, don't count it twice. You must subtract that out. If they do not have anything in common, you just add their two probabilities together. I'm going to show you several examples here so you can kind of see the difference. All right, a card is randomly selected from a standard deck of 52 cards. What is the probability that is a 10 or a face card? Now, think about, here's all the 10s, here's all the face cards. They have nothing in common because a 10 is not a face card. So to find the probability of a 10 or a face card, remember when you see the word or, you're thinking about addition, you're going to add the two together. So they're probably getting a 10 is 4 out of 52. They're probably getting a face card. That's how many face cards there are. There are 12 face cards, 12 out of 52. So you get 16 out of 52, which is if you reduce that, you get 4/13. If you change it to a decimal, you get 0.308. So one of those two answers right there is fine. But that's called mutually exclusive or disjoint because they had nothing in common. All right, a card is randomly selected from a deck of 52 cards. What is the probability that is a face card or a spade? So now I'm thinking, okay, probability that is a face card or a spade. Okay, so they do have things in common. So let's take one at a time. Probability of face card. Remember, there are 12 face cards from the last slide, so 12 out of 52. 1/4 of the deck is spades. That's 13 out of 52. Now, what I have to subtract out is what they both have together. Like, what do they have in common? How many face cards are spades, like face and spades? That's what I'm subtracting out here, face and spades. And there are 3 of those. There's a jack, queen, king of spades. So I'm going to subtract out 3 out of 52. When I add those up, I get 22 out of 52. Reduce that one down to 11 out of 26. And there's your answer. Not a very good 11 out of 26, but there it is. Okay, so hope you see the difference in those two slides, those two problems. That's a big deal for tomorrow. All right, out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. I'm going to make the varsity athletes be event A and the honor roll be event B. There are 74 seniors who are varsity athletes and 51 seniors who are on the honor roll. What is the probability that a randomly selected senior is both a varsity athletes and on the honor roll? Now, we haven't learned how to do and problems yet. That's coming soon. So what we're going to do is we're going to use the formula we used earlier to solve for and. Okay, here's the formula. I already wrote it down here. This is the formula we're using. Probability of A or B equals probability of A plus probability of B minus A and B. So I'm going to solve for this. So probability of A or B was given in the first sentence. 113 are athletes or honor students. So I'm going to go ahead and write 113 over 200 there. And that's going to equal probability of A. A is, I said, varsity athletes. There are 74 varsity athletes out of 200. And 51 honor roll, that's B. 51 on the honor roll minus P of A and B. All right, so what I'm going to do is I'm going to move over the 74 over 200 and the 51 over 200. So I'm adding these together, then I'm going to move them over to that side over there. When I do that, I end up with negative 12 over 200, which, if you drop the two negative signs, that's going to be your probability of A and B, which is what the question was asking me for. So 12 over 200 reduces to 6 over 100, which keeps on reducing to 3 over 50. So you can write your answer 3 over 50 or 0.06, either one. So I actually had to use the formula, kind of go backwards that time. So make sure you have that formula down from that slide earlier where I told you make sure you get that stuff down. All right, probability of a complement. The complement is basically the opposite of it happening, or probability of it not happening. And the way you write complement, you're going to see with a little a or whatever with a bar over it, that means complement. And the way you find the complement is 1 minus p of a, probability of a happening. For example, what if I want to know the probability of getting not a 5 when I roll a die? All right, so I'm going to do 1 minus probably that I'd get a 5. You have a 1 out of 6 chance of getting a 5. So if you do 1 minus 1, 6, you would get 5, 6. So the key word there being not. And a lot of times we're going to do not to solve things, even whether it's a not problem or not. Oh my gosh, that sounded weird. We're still going to use it. Let me show you an example. I think it'll help better. But the way you find a complement always enters a bar or b bar, whatever. It's 1 minus probability of a. Okay, here we go. All right, example of using complements. It says when 2 6-sided dice are rolled, there are 36 possible outcomes as shown. They're all right there. Find the probability of the given event. It says the sum is not 6. The way I'm going to do the probability of the sum is not 6 is I'm going to do this. I'm going to do 1 minus the probability that the sum is 6. Okay, 1 minus that, because it's easier to count. There's so many where the sum is not 6. It's easier to count the ones where the sum is 6. So let's see here. There's a 6 right there, 4 and 1. 4 and 2, 5 and 1, 3 and 3, 2 and 4, 1 and 5. So there are 5 of those. So I'm going to do 1 minus 5, 36, which will give me 31, 36. And that's all you do. That's how you use the complement. That's a smart way to go. The second one says probably that the sum is less than or equal to 9. So they're asking me to do this sum is less than or equal to 9, which is a bunch of those dice in there. So what I'm going to do instead is I'm going to do 1 minus or probably the opposite, that the sum is greater than 9. So I'm looking for everywhere where the sum is greater than 9. Let me see if I can erase these real quick. I'm looking for sum is greater than 9. Greater than 9, there's a 12, there's an 11, there's a 10, there's a 10, there's an 11, there's a 10. And that's all I'll find, which is 6 of them. So it'll be 1 minus 6 over 36, which is 30 over 36, which reduces down to 5/6. And there you go. That's how you use complements. A very smart way to use them. Okay, your book categorizes this one as a complement in a real life. So let's see what it says. A restaurant gives a free fortune cookie to every guest. The restaurant claims there are 500 different messages hidden inside the fortune cookies. What is the probability that a group of 5 people receive at least 2 fortune cookies with the same message inside? So they want the probability of at least 2 being the same. Now, when I see at least 2, I'm thinking opposite, because we just did complements, and that's the way to go here. Because if you had to do at least 2, you have to do 2 or 3 or 4 or 5. You have to do probability like 4 times. So instead, what I'm going to do is this: probability that none are the same. Because the opposite of at least 2 is less than 2, which is just 1, which is the same thing as none are the same. None are same. So I'm going to do 1 minus that. Now, the hard part is I got to figure out how to do that. Okay, so if there are 5 people and they are each getting a cookie, the first person has a choice of 500 different messages they could get. The second person, because they have to be different, will have 499 choices. The next person, 498. The fourth person, 497. And the fifth person would have a choice of 496 messages that they possibly could get. Right now, my denominator is all the different ways. Okay, all the different ways. Remember, there's only 500 ways and 500 messages, and each one could get the same. So the bottom's going to be 500 times 500 times 500, 5 times. I'm just going to write it this way. This is a definite calculator problem. I'm going to punch that in my calculator. I'm going to put this in parentheses, obviously. 500 to the 5th in my denominator. Punch it in, and I'm getting 0.0199. not very high probability that that's going to happen. Basically just under a 2% chance that can even happen. So just with 5 people, even with 500 different messages, which is, when you think about that, that's kind of crazy. All right, I hope that made some sense. This is going to be something where you get better with practice, and we'll definitely be practicing on these things tomorrow. It's a thing where you get a good understanding, some understanding from the video, but coming to class tomorrow is really going to help. So I'll see you then.